Hello, everyone. This is final exam review, the last one. I have already said that final exam will start tomorrow by 6 p.m. The announcement is posted already. Tomorrow is going to be 4th of April, 29th of April by 6 p.m. And the final exam will end on the 30th of April by 6 p.m. All right, so you have to do your best. Remember, final exam is a standalone test. So everybody must take it. That's what it means. If you don't take it, it's not going to be good because you make a 0 for that standalone grade. And one good thing is that final exam, if you do very well, it will replace your lowest test grade too. So it will be good for you to take it and do very well. Remember, it's comprehensive. It starts from unit 1 to unit 4, which means from chapters 1 to 10. So these questions here, first, if we scroll down, these questions here are sample questions. They are not going to be exactly like this, but these are sample questions you may see the final exam. So what I'm trying to say is that if you know all this, then you are ready for final exam. So it contains everything we have talked about, everything, almost everything, bit by bit. So you have to know every bit of it. But one good thing is that all the videos you need to make an A in final exam, all the videos are in Blackboard. All the videos are in Blackboard. And don't forget that the author has a video for each section of chapters 1 to 10. The author has a video for each section. So that is an advantage. So take advantage of the author's videos also. So you choose which video to watch, the class videos or the author's videos. All right, so we're not going to do a lot today because no matter what, we will never cover everything from chapters 1 to 10. I've already said that you have everything you need to make an A. Okay, so let's just do as much as we can. We start from number 1. What you want to do is when you're taking this exam, you want to start from the one you know. You start from the one you know. Make sure you get a first impression, a good first impression. All right, so let's look at question number 1. Question number 1, practice. This is a practice test, though. It's final exam review. So question number 1 says, what are the 2 requirements for a discrete probability distribution? So first of all, you have to remember the properties of a discrete probability distribution. What are the properties? It is discrete. It's a probability. So first of all, it has to obey all the rules of probability. And it's discrete. So remember, it can have so many probabilities. But the question here is asking you about the requirements or properties. So let's go and look. We already did a lot of this. So what are the properties of discrete probability distribution? 1, the sum of all the probabilities must be equal to 1. The sum, which means the total probability, sum of all the probabilities must be equal to 1. The sum must be equal to 1. Cannot be less than 1, cannot be greater than 1. So that's one property. The second property of probability is that the probability of an event is not allowed to be less than 0, cannot be negative. Cannot be negative. So the probability of an event cannot be negative, and it cannot be greater than 1. What am I trying to say? So actually, if I explain this in mathematically, or is saying that the probability of an event, any event, is not allowed to be less than 0. probability of an event is not allowed to be less than 0. This question must be in the exam. It's there already. So at least it's an easy question that you should be able to take advantage of. Because really, that is the main thing somebody's going to ask you. If you don't know the properties of probability, then you really you probably wouldn't know what to answer in the test. Okay, so we're trying to explain this second one. The probability of any event is not allowed to be negative. That's what this means. Also, the probability of any event cannot be greater than 1. So probability of any event is not allowed to be greater than 1. It can be 1, but it cannot be greater than 1. For example, if you solve a probability question and you have 1.2, 1.3, or 2.4, your answer is wrong. You tell yourself that, because that disobeys the probability rules. So I can use a number line for property number 2. So I use a number line, and I want to draw a number line covering property number 2. You must know these two properties. That's probably why it's number 1 question. So if you draw a simple number line where the endpoint is 0, the upper bound is 1. This number line is saying that the probability of an event is not allowed to be less than 0, cannot be greater than 0. That is why you can use 0 is less than or equal to. Probability of an event is less than or equal to 1. So that's a compound inequality there. Okay. I want you to know that 0 is less than probability of an event is less than 1 does not pass this. You see, this will be one of the options. And it looks like the other one. But the first one here, A, is not the same. If this is A and this is B, option A is not equal to option B. Why? Because option B is trying to say that the probability of an event is not allowed to be 0. It's not allowed to be 1. It means that the compound probability is open-ended on both sides. All right. So this actually means that probability can be 0. If the probability of an event is 0, it's said that is a null set. It's uncertain, can never happen. The probability that you are taking the same exam by 6 p.m. tomorrow, or you are taking 3 different exams at the same time. At the same time that you're sitting in 3 exams, cannot happen. Yeah, some things cannot happen. If they cannot happen, then you say it's uncertainty. All right. If the probability of an event is 1, then it's certainly going to happen. Certainty. If the probability of an event is 1, it said it's certain. It's certain to happen. Okay? So that we're not going to say a lot, but we already know this before. We knew this before. So just making sure we remember. All right, so that is question number 1, even though it's question number 1, but everybody needs to know that question number 1. It's easy, but everybody needs to know that question number 1. So let's go to question number 2. Question number 2 is actually a hypothesis test question. And it is, by the way, you should look at it and know what it is. You should look at the question and know what the question is. So if you look at that question, it's telling you to test the hypothesis using p-value. So you have to remember what p-value is. There are too many things to remember. What is p-value? When do you use it? what are the conditions for using p-value. That's not what we're not going to teach everything today because they are all in the videos. So you might want to take time and watch the videos. It's possible when you are watching the videos, take notes. Take notes that you will read again by tomorrow. Handwritten notes, whatever way you like to take notes, but take notes. The videos from class sessions and video from the author, they're all almost the same. Just whichever one you like, watch that. Be sure to verify the requirement of the test. So what is the requirement? This is a p-test. If you don't know, I hope you know by now, you know, when the null hypothesis, it says p is equal to 0.3, then the status score is 0.3. And then you're going to contest this status score. And it's a right tail test. How do you know it's a right tail test? Because you're told that alternative hypothesis is greater than 0.3. If you like, you can just draw a number line. So if you like, draw a number line. So, I mean, not just a number line, but draw the normal curve. So I'm going to clean up this. Let me clean up this side of the whiteboard. I can just move it up. So I'm going to move up the whiteboard and, all right, start that question. Then I'll finish it because really the essence of doing review is to maybe eyeball every question in this, not doing them, doing all of them. Eyeball the questions here and see the kind of questions you need. So you need to remember hypothesis testing for proportion, and you also need to remember hypothesis testing for population mean. Okay, so this test is, I can start by writing. I'm already given the status quo. Status quo is P. By the way, it is a proportion test. So P has to be, and remember that the status quo goes with equal sign, and you're given the status quo as 4.3. If it is proportion, your status quo has to be in a decimal. Okay, so you can write it in percent, 30%. That's okay. So this is the null hypothesis. If I want to say 1B, the alternative hypothesis, I told you I like to write alternative like this. Well, we already given that the alternative hypothesis is P is greater than 0.3. That is what the question gave us. So I can actually draw a small, and I will show the critical value. But how do I show the critical value? I will check to see if I'm given I already know it's a right tail test. I'm told it's a right tail test. So I want to find where, did they give me alpha? Okay. There are so many things I need to know before I start. By the way, it's a p-test. Therefore, it should be able to pass the conditions for converting a binomial to normal. In other words, is the variance greater than 10? If the variance is greater than 10, then you can say Z, the critical value on the right-hand side. You will not divide alpha by 2. Okay, so you can say Z alpha. You'll be given alpha. So let me check. So let's do the check for conditions. So we are given N, sample size to be 125. We are given X to be 43. All right, so let's see what we have. And the important thing right now is that NPQ, I can use the population. So is NPQ greater than 10? So let's do that. Is NPQ greater than 10? So what I'm going to do now, this out right here. Okay, N is 125 given to me. So 125 multiplied by P is 0.3. If P is 0.3, then Q is 1 minus 0.3, which is 0.7. Then at this point, I'll multiply this. What am I looking for? I'm looking to see if this product, NPQ, the variance of the, is the NPQ greater than or equal to 10? Is the variance greater than or equal to 10? So I'm going to find out. I'll multiply that using my calculator. Let me fish out where my calculator is. All right, so now I am going to type in what I have there. N is 125 given. P is given to me as 0.3. Q is given to me as indirectly as 0.7. So I'm going to multiply this. What am I looking for? The product. The product is 25.2, approximately 25. Approximately 25. So if the product is this 25 right here, the product is 25. Let's see. So the product is 25. In other words, NPQ is greater than 10. The variance is greater than 10. Why? Because 25 is greater than 10. In other words, condition number 1 is passed. Right? So condition number 1 is passed. NPQ is greater than 10. If you don't do this test, you don't want to start your hypothesis test. Okay, so the next one is what is the sample size? Is it less than 5% of population? Of course. So 125 sample size of 125 is definitely less than 5% of 360 million. You can check this out by dividing 125 by 360 million. The answer will definitely be an insignificant number, which means that this 125 is less than 5% of the population. So conditions are satisfied. So we can continue the test. So the conditions are satisfied. So I'm going to minimize this and then go back to see what else. What else is the question? So what else am I asked to do? So I'm given alpha to do this right cell test. I am given alpha. I am given X. So then I'm going to continue. So I'm going to minimize this. I will continue. And what I'm going to do is move this up again so that I get a white space. All right. Okay. And see what I'm given. I'm given that alpha is 5% or 0.05. So alpha is 0.05. To do the right tail test, given the random variable of 43, I'm given the sample size of 125. I already know that. So it's time to calculate the test statistic. Well, call it test statistic. Okay, so P hat is equal to random variable of sample size. I hope you remember all this. You have to remember all this. So, and this is in chapter 10. All right. So the random variable given to me is 43. Sample size is 125. So I can calculate P. So I'll quickly find the approximate value of P hat. So 43 over 125 is the P hat. I know there are so many things to remember. I know that. But if you just take your time, watch the video. Remember, we have done this before. So they are all in test number 1, test number 2, test number 3, and test number 4. So divide by 125. And then I hit enter, and the p hat the point estimate is 0.344. So the point estimate is 0.344. I don't really have to evaluate that, but anyway. So P hat is 0.344. 0.344. So I'm using this P hat, which is the sample statistic, to test the population parameter, which is 0.3 given to me. The population parameter is called the status quo. And I'm given that status quo, and I'm given the properties of a sample. So the P hat from a sample point estimate give me this. It's time now to do the test, so that because all the conditions are satisfied. So I'm about to do the test. Be sure to verify the requirement. Okay, test. Remember, number 2 says test the hypothesis. So I'm actually testing the hypothesis using p-value. Remember, the question says use p-value. And remember, you can use your calculator. Unless you don't know how to use your calculator, but really, you need to use your calculator to do the test. Okay. So how do I do the test? I'll go to STAT, arrow to test. And what kind of test am I doing? I'm doing a hypothesis testing. And this P has passed all the tests for proportion to convert to normal. So, which means I'm doing one prob Z test. One prob Z test. This binomial passed the test. So I'm doing one prob Z test number 5 in my calculator. So I select that. And it's asking me what is the status quo, 30% upon 3. And what is the given random variable, 43? What is the sample size, 125? What kind of test am I doing? I'm doing a right tail test. So I'm going to scroll up and select. You know, my calculator already knows that there are 3 kinds of tests. But I'm either doing a right tail test, left tail test, or 2 tail tests. So in this particular question, I'm doing a right tail test. So I select, and then I'm going to draw. One thing you want to know is that this question will be in the test, but it will not be the same numbers. The numbers will be changed. So there is nothing like memorizing a question in the practice test. That will be a waste of time, because when I'm going to reshuffle the question, so it's not going to be the same numbers. So there will be nothing like memorizing the question, but knowing the steps and how to do the question is the most important. All right, remember, this question says use p-value. So you must know the conditions for using p-value. What are the conditions for using p-value? So the conditions for using p-value is that if p-value is greater than alpha, by the way, what is the p-value here? I see that the p-value is 0.1415. So let me write it down. And then we talk about the conditions. So the p-value I got from this is 0.1415. P-value that my calculator gives me is equal to 0.1415. So this is p-value. I need to make a decision with this. I need to know how to make that decision though before I start. So how do I make that decision? Remember, we emphasized this in class. We said that to make a decision, hypothesis test decision with p-value, you will find out, compare p-value with alpha. So what is alpha? Alpha is 5% given to me. And what is p-value? If I change this to percent, I have 14.15%. So 14.15% is greater than alpha of 5%. So if p-value is greater than alpha, you accept the null. In other words, do not have enough evidence to reject the status quo. So in this particular case, p-value is greater than alpha. So the decision is that I will accept the null. So I do not have enough evidence to reject the status quo. The null is the status quo. In other words, even though the sample statistic gave me 0.34, something greater than the status quo, that sample may not be a good sample because from the test, from the p-value, the status quo is still working. I do not have enough evidence to accept, to reject the null hypothesis. I do not have enough evidence to reject the null hypothesis. All right, so what is the conclusion? I will go and call those who hired me to do this test, and I will tell them that from the test, from the study, I found out that the status quo is still working. There is not enough evidence to reject the status quo. So we can still use the null. It's still working. You don't throw away what is working. So because probably they don't know, if they know it, they will not ask me. They won't ask you, the businessman. So they ask you as a statistician to do the test do the study for them and give them the result. And probably they paid you. So you're not going to be speaking statistical jargon to them. You will not be saying p-value is equal. You cannot be saying alpha because they don't understand those. So you reply to people who hired you in non-technical terms. You reply to them in non-technical terms. I do not have enough evidence to accept the null hypothesis. I have enough, to reject, by the way. So we did not reject the null hypothesis. And what is the null hypothesis? The status quo, what they believed before. I guess some people said it's no longer working, so they want it changed. But anyway, after the test, they just found out that it is still working, doesn't need to be changed. There's no way you can throw away what is still working. Okay. Okay, so that is question number 2. As I said before, I don't intend to do all of them. There's no way we can do chapters 1 to 10 today. There are so many things covered here. So we just, this is just a review. But what you want to know is that whatever I'm saying today, they're all in Blackboard. So when you get your answer, you have to explain all this, put in the value of the variance. This is the variance, put in the value, answer the question, put in the p-value, answer the question correctly. And then remember that the computer doesn't know who you are. Computer is going to grade your paper. So be careful to answer the questions correctly. All right. So everything will be there. Normal distribution, confidence interval, hypothesis testing, whatever. And I put in the charts just in case you like to use the chart to read. So there are a lot of things: conditional, probability, joint events. I just want to, I'm just saying what is in the text so you know. Joint and disjoint event, which means mutually exclusive event and non-mutually exclusive event. Look at number 4. So you should actually know the formula. If E and F are not disjoint, you see, they just ask you this question to see if you paid attention. Why would they be asking you this kind of questions? So let me clean some part of this. Okay. So see, there are some statistical jargons you must know, must remember them. So there are some things you need to remember. What is disjoint? You have to know what is disjoint to know what is not disjoint. All right. So if E and F are not disjoint, if they are not disjoint, then they are disjoint. So you have to interpret that. If they are not disjoint, then they are disjoint. If they are not disjoint, then they are joint. See, the question says if E and F are not disjoint. So you have to interpret that. If they are not disjoint, then they are joint. So you draw a picture. Or were you? I'll draw a picture. What kind of picture are you going to draw? You draw a Venn diagram. Draw a Venn diagram and show two events that are joint. Draw a Venn diagram, show two events that are joint. Okay. It's bigger now. All right. Okay, so let's say that this is A, event A, and this is event B. Event A and event B are joint because I'm told that they are not disjoint. Well, let's call event A E. This is E, and this is F. Okay, and if they are joint, then I better be using the general rule for all probability. All these are in Blackboard. The general rule for all probability is written as the probability of E union F is equal to the probability of E plus the probability of F minus the probability of E intersection F. E intersection F. So one thing you want to do is that, you see, this here, shaded region, is in both of the events. The shaded region is in A, is in B. So you are trying to take away this shaded region one time because it is, if you don't, then you're double counting. So remember we did this, so go back and read it because really there are so many other questions. So we're not going to waste time, but you have to know the formula though. And actually the question is asking you about the formula. If E and F are not disjoint, then P, so this, they only ask you about the formula right now. And by the way, the formula we are asked to do is this. So you're told to write the formula. All right, so that's the formula here. So it is PE plus PF minus. The minus means you have to take away you don't want to double count. And that's all the question in this. That's as easy as that. That's an easy question. All right, so, but at this point, there are too many things to remember. But I didn't make it. The rule in our school is that everybody take final exam, and final exam is comprehensive. So I can't change the rule. That's what I'm told to do. I'm doing. All right. Okay. So one thing I want to let you know is that all the questions here, you have seen them before, but they are not exactly going to be the same numbers. The numbers will not be the same. So you must know how to do them. You cannot memorize them. That's all. Otherwise, you know how to, these are there already. Okay, number 5. Determine whether the distribution is discrete. We already talked about that. This is very important. Is it discrete? How do you determine that? Okay. This is in unit 3. If this is discrete, none of the probabilities will be negative. In other words, it has to obey the 2 rules of probability. The sum of all the probabilities must be equal to 1. What does that mean? You have to pick up your calculator and add all the probabilities here. Add all the probabilities there. Make sure that it's equal to 1. That is row number 1. Okay, and rule number 2, you check these probabilities. Is there a negative probability? No. So the most important one to check now is to add all the probabilities. The other one is already satisfied. So I pick up my calculator and add all and that's all the question. I don't even think they asked you to find the mean. They didn't even ask you another question. That's a simple question. Because they can actually ask you to find the mean, the standard deviation, the variance, and so on. But they did not. They just ask you, is it discrete? That's all. In other words, add up all the probabilities and add up all the probabilities. Find if they are equal to 1. So let's do that. So we want to add up all the probabilities and see if they are equal to 1. Okay. So 0.19 plus 0.2. So that is 0.29 plus 0.28 plus 0.15. What are we trying to do? We want to test that this passes the rule. And then plus 0.09. All right, so I will enter, and the sum of all the probabilities is exactly 1. And if you check and it's not equal to 1, you want to go back and add it again. You might have made a mistake. People make mistakes. And this is an easy question again. You don't want to miss because you made a mistake. And there are 20 questions. Each question is 5 points. So each question is 5. Whether it's simple or difficult, each question is 5 points. So if a question is going to take you 30 minutes to solve, get away from that question. Do the easy questions first. If a question is going to take you more than 5 minutes, because there are 20 questions to be done in 90 minutes. So do the easy questions first. Make sure you do the easy questions first. All right? And therefore, you can now conclude. Therefore, the distribution is a discrete probability distribution. Why? Because the sum of all the probabilities is equal to 1. There is no negative probability. You can write it down if you want to. You can say the sum of all the probabilities, the sum of all the probabilities is equal to 1, and there is no negative probability. In other words, you can write it this way: 0 is less than or equal to probability of an event is less than or equal to 1. So there is no negative probability. There is no negative probability. The sum of all the probabilities is 1. There is no negative probability. Okay. All right. Then that is number 5, and you should be able to choose the right option there. If you know the rules, choosing the right option will not be difficult. This one is unit 1. Find the sample variance and standard deviation. This is a simple question, but people miss it all the time because they forgot what the meaning of parameter and statistic. People who forget the meaning of parameter and statistics miss this question. Find the sample variance and standard deviation. Okay. So what you're going to do is go to your calculator. You don't have to, but if I were you, I already told you several times that as much as you can, use your calculator so you can finish the test and do very well. So I'll pull my calculator up, go to STAT, and go to Edit, and put in all these numbers. It's a very simple sample. So I have 18, so I type it in, 18, enter. Individual number 1, every number is an individual. 16, enter. 2, enter. 6, enter. 11, enter. When you finish, remember that you are a human being. Human beings make mistakes. So take your time, go back to what you entered and review. Excuse me. Go back and look through what you typed in and make sure that you didn't make any mistake. Whether it's a simple sample or a large sample, doesn't really matter. Whenever you finish typing a raw data, make sure you go back and check and see if there's any mistake. Now that I see there's no mistake, I can go ahead and find the sample variance. Before I find the sample variance, I have to find the sample standard deviation. And by the way, I need to remember that variance, sample variance, and sample standard deviation are just a statistic. What is going to be the difference? You must know that difference. That is going to be the problem. Some people will not know the difference. Let's explain that again. So what is sample variance? What is sample variance? What is the population variance? So let's say that again. Parameter belongs to population. Whatever you call parameter belongs to population. Okay, so parameter. So population variance is written as sigma squared. This is variance. Population standard deviation is written as sigma. Sample variance is written as S only, sample variance. So this is sample variance. Sample standard deviation is written as S. And every characteristic of a sample is called statistic. Statistic. Every characteristic of a population is called parameter. So in this particular question, they are actually trying to see if you still remember your unit 1. You still remember the difference between parameter and statistic. So that is why they're asking you this question. There's no way you can forget this when you did statistics. Okay. Okay, so watch how we are going to use this now. So I type the data in my calculator. I want to find the variance. So I go to STAT and I go to calc. I do one variable start and I'll do one variable start of L1. Do I have frequency? No, I don't have frequency. So I'm going to calculate. In other words, this is a raw data. I don't have frequency lists. So I'm going to calculate. So now I see that the mean, remember I'm not asked the mean. So, but X bar is 10.6. So I'm not asked the mean, but I'm told to calculate the sample variance. One thing you need to know is that there is sample variance in this one variable stat. There is population variance also. So if you want to copy it out, you copy the one written S of X. So I'm going to pull this up. All right, so go ahead and come out. I don't know why you're hiding. All right, so I'm just going to pull it up. So it's trying to hide. So what it's hiding? I'm trying to get on my whiteboard to open up. All right, so if you don't want to open up, I just okay, my sample variance is going to be S squared. You can see S sub X. my sample standard deviation is going to be X. So I'm going to pull my calculator up and find them. What is the number, or what are the numbers? So you notice that the sample variance is, and by the way, if I just want to get the exact number, I'll just go to var statistics. So I'm just going to go vars and statistic, and I'm looking for sample variance, which is number 3. If I hit enter, I get the standard deviation, which is to 2 decimal points, I have a 6.69. But if I square it, I have the variance. And I have the variance to 1 decimal point as 44.8. So 44.8 is the variance. 6.7 is the, so this is 6.7, 44.8. What's the difference? Yeah, I will come over here. Everybody must pay attention. Come over to A and put in 44.8. And I will go to the second one right here, where written S, and write 6.7. What's the difference? If you write your answer in this for sigma, the computer marks your answer wrong. If you put it as variance of a population, the computer marks you wrong. Remember, the computer doesn't know who you are. So you must make sure that you're entering the right column. So this question actually is finding out if you know the difference between a statistic and a parameter. Do you know the difference between a statistic and a parameter? You know the difference between a statistic and a parameter? So that's all the question is asking. All right, so I'm going to be cleaning this section again. And then I'm going to move, we're not actually trying to do all of them. That's not what we can do all of them. I'm just trying to remind you what we did for this semester, because everything we did this semester, one way or the other, will be there. So everything we did will be there. So I am going to move down to this one is binomial distribution. And then question number 7 is binomial distribution. There are so many things to remember here. I want you to know that the question asked you here is you are told to find the probability that the random variable is as you accumulate from 4 to 0. But first of all, sample size is 11. Remember the binomial formula. Okay, a binomial probability experiment is conducted with the given parameter. Compute the probability of X successes. Let's see. And N trials, the number of trials is 11 under N trials. Okay, so what you're going to do, first of all, remember the formula for binomial distribution. So you will, first of all, maybe write the formula if you need that. So N combination 4, 11 combination 4, and this particular 11 combination 4, success is 0.15 to the power 4, and failure, if success is 0.15, then failure is 0.85. And to power 11 minus 4, if you subtract 11 minus 4, you have a 7 here. By the way, you are doing binomial cumulative density function. Why? Because you are accumulating from 4 down. You are accumulating from 4 down. So binomial, I'm going to show you quickly where you find it. And actually, I think we are going to stop here because there's no way we can do all of them. So I'm going to go to the calculator, show you where you're going to find binomial cumulative. You already know that. And this is unit 3. So you want to go and study unit 3 because the final exam is cumulative. So where do you go to find binomial cumulative density function? You go to distribution, so second verse, and where is binomial? Remember, it is not normal. It's not any of this. So your arrows keep on looking for binomial. And it's cumulative because I'm looking for P0 plus P1 plus P2 plus P3 plus P4. So that is why I'm using cumulative density function. So I'm going to select that. A number of trials is sample size. That's one of the properties of binomial. You must be given the sample size. Probability of success given to me is 15% or 0.15. The X value, random variable, is 4. And I'm using exactly 4 because 4 is included. And I'm going to calculate. If I calculate, I have a whopping 98.4%. So the probability of getting the given parameter, remember, it's probability. So your answer must be less than 0. The answer cannot be less than 1. Okay, so compute the probability. So the question says compute the probability of X successes. In other words, getting that any success from 4 to accumulating the probabilities. So that probability is 98.4%. I think we're going to stop here because really there are so many things to review. I'm going to give you time to do your own review. If you do have any questions, send me an email. You cannot miss final exam. Final exam starts tomorrow. There will be no excuse to miss final exam. Starts tomorrow by 6 p.m. and I'm giving you a whopping 24 hours. Don't forget that I know you work. Don't tell me you went to work. That is why the final exam will start by 6 p.m. So if you work during the day, you will be able to do it at night. If you work night, you will be able to do it during the day. That's why I'm giving you 24 hours. I understand that you work. That is why attendance is not compulsory. So, but doing your assignments, taking final exam is compulsory. So you must take final exam. All right. Okay. So final exam will open tomorrow and I will send you the password by 6 p.m. I know I'm repeating it, but I can repeat it because it's important. Final exam will open tomorrow by 6 p.m. Tomorrow will be 29th of April, and it will be due on the 30th of April by 6 p.m. You can take excuse from your job if take a day off. I mean, whatever you can do to do well because final exam is very, very, very important. Final exam is very important. If you have any questions, send me a question. I wish you good luck. I know that if you study, you will do everything you need. I already said that. Everything you need to make an A, I gave them to you. I know what you don't have. You don't have time, but well, you can make out time so that you do well, okay? Good luck. I'm going to stop so far.